Right, so welcome to MG5002 Engineering Mechanics. Our topic for today is called friction. The content for today is very small, so friction topic, solving 3 different examples. One of them will solve the example with 2 different scenarios. We'll see what's the difference when you change the direction of the motion towards the friction force. So we start with this example 1. You need to bring your calculators and a piece of paper so you can try it, and then you share the answers and then we can see it. So example 1, if mu for both bodies is 0.268, so the coefficient of friction at that point between this 120 newtons block, it's 0.268, and as well the same thing here. Find the force P needed to cause movement towards the right. So the movement is actually in the direction of the force. It's very important to identify these things so we can clearly understand the difference. Sorry. So if we do some analysis for this kind of like sketching a free body diagram, and we can say which block is easy to start with. So if we look into this, the 80 newtons block, you have a tension going in that way, trying to pulley based on the weight of that block, 120. Logically, the 120 newtons is bigger than the 80 newtons, since the weight is equals the mass times gravity acceleration. But we don't know the amount of the force P, which we're trying to pull the both blocks on the right direction. So here I have normal force, friction force, and tension. So it's easy to start with this block, and then whatever information we get, we can take that friction here. We assume the pulley it's frictionless, so whatever tension is applied here will be applied on the other side. That's an easy assumption to make it very easy for us to solve the question. All right, so let's start solving the question. We start with solution, and then we say, how can we start this with the first block? So very easy. Oh no, I selected the wrong one. You just create a line like this, and then you bring a tiny box, and that box you rotate it in that way. You must make it like kind of on top of that one. Hopefully that will be very close. Now, what we know from that block, that the mass or the newtons, the weight of that, which is equals to 120, it's going downwards. Very important to write the units, and it's kind of should be in the center based on the center of gravity. We know that this angle is 30 degrees, therefore we'll have a components of this for that one. Okay, we got a couple of questions. Let's check. Yes, hello. So we need just to draw a perpendicular in that direction and then another one on the other direction, so we can show the components of the weight. Now, what we say, the direction of the motion here is going to the right, so that the way is the direction of the motion. So we always sample it like this, and we write D or M, which is spells or stands for direction of motion. Since is that what's happening here, it's very easy to say that the friction will be opposite to that direction. So you always have a friction going in that way at that point. Let's choose different color. This may be red, and we call it friction, FF, force of friction. All right, 1, because we have 2. One is for that box and the other one. And at the same time, since this force is acting in that way, so definitely we'll have a normal force going in that direction, which we'll call it normal force 1 against the crate or the block we're trying to move. So N1. All right. So this is easy way to sketch the free body diagram for the first block. Reason I choose this one, because I believe we will have less information, or at least one unknown, and based on it we can determine the value for it. All right. Again, it's very important for us to specify the coordinates for solving any problem. So this is my X. I'll choose the green color to distinguish between them, Control V, and this is my Y direction. Based on it, I can determine which way I'm going, X or Y, and how can we find the analysis for that. Since now we've done everything, I need to just make analysis the components of the weight. So one will be going in that way, which is the analysis of that force with respect to the angle. I haven't done the angle yet. I will do that. The weight as here, which is opposite to the normal force. And I need to justify the angle, which is 30 degrees. So I write 30 and I put the degrees to make sure we're solving it in degrees, not in radians. So this angle, because this is 30 by mathematics, this will be trigonometry, will be 30. So that the free body diagram for that block, the 120 newtons. Now, from the equations we learned, I need to determine what's the T, which is the tension available on that direction. So I will need another information to add here. It's that tension, which is kind of applied at that position. We'll sample a T. It's very easy for us. Because we assume the pulley is a frictionless, therefore T, and it's equal between that point and that point on that tension. So that's T. I look again to the question. I put my weight. I put the normal force. I put the friction force, direction of motion. Direction of motion, if we really become more realistically, it should rotate in that way. And we make that this so we can understand that's the direction of motion. My X and Y coordinates are here. So this is X, and this one is Y. Y. And then we just move it to here. So now you know everything. Anything I need for that block, if you guys have missed something, just let me know so I can correct it. But I'm revising it before I solve the question. So I did include the weight. I did put the normal force, the friction force, the tension, my coordinates. I did kind of showing you how we will do the analysis for the 120 newtons. Now I need to move next. So I will give you time to find me the value for T and the value. Yes, we need from this the value for T. So I'll give you time to find the value of T as at the same time I'm taking the attendance. Cool. All right. Now we start solving the question. We type here and insert equations, algebraic summation of forces in. Let's say that we start first with the Y because we have less information. In the Y direction, you have the normal force one, and the opposite to that is the weight of the crate. So this will be equals to normal force one. So N1, normal force, equals to opposite to that is the 120 cosine 30 degrees. So if you use your calculator, this will lead you, and it's equals to, I lost my mouse here, and equals to, like, let's say, put this again. So N1 equals to, if you have your calculation, can you tell me the value for N? I'm waiting. Come on, guys. So it's cosine 30 times 120. The answer is 103.9 newtons. Don't forget the units. Well done. You're done. You did write the units. And that's how it works in this question. So now we determine the value for normal force for the first block, which is very important. I'm repeating this. It's very important to identify which block. Otherwise, you may get something confused between the two values for them. Okay. So since we solved that, now we can find algebraic summation force in the x direction, and will be very interesting. So I'm copying the equation again. I would just easy for me to edit this equation to save time. This will be x is equals to 0. So what we have in the x direction, I need to repeat this. So in the x direction, if you look carefully, I have T, which is the tension, is going in positive, minus I have the force components, 120 sine 30 degrees, and insert the angle is 30. And what else do we have in there? We have minus the friction force. So at this stage, I'll write friction force because I want to do it step by step so you guys can learn how we're getting that. And the rest of the equation, I would just cancel it because it's not important. So that the equation equals to 0. So the tension minus 120 sine 30 degrees, sorry, and then minus the friction force 1. Here, to make it more clear, I could put 1 so we understand there are two frictions and which one we are talking about to not confuse anyone comes when they read this question. Again, I'll give a break so you guys can solve this question while I'm taking the attendance. Cool. All right, so let's continue with this. And then if that's the equation, now what we know from our equations, the friction, it's equals to what? We have an equation for it. It's kind of very funny. So insert, and let's do it again. So F1 equals to mu, which is the coefficient. And here for you, if you want to type your report, this is very good, guys, for you when you try to type your reports, times what's N1, the normal force 1. Don't confuse because we have two normal forces in this example. All right, so that's the equation. Now, what's the mu? As you can see, it is giving to us 0.268. So 0.268 times the value for N1, which is 103.9. And that will be equal. Can you give me the answer, guys? I'll wait for you to give me an answer for the friction force 1. Still waiting. Good, good. I start getting. I'll give you time for the other guys to answer. I got 2 answers correctly. Right, the rest of the group. Come on, guys. Good. So start coming the answers. So if you get the answer like what we're trying, which many of you getting it, so it's 27.85 newtons. One thing I need to tell you in this for your reference in the future, it's recommended you split the numbers towards the unit. So you always have a gap between them, and newtons is always like what you see, this capital letter. So when we got the friction force, now we go back to this equation. I forgot to call it equation 1. We can substitute the value of F1 as a 27.85, and we rearrange the equation. So I will, because of time, I will recopy this equation again and show you how can we edit it. So if I move everything to the other side, we'll be keeping the tension here. This one will be positive, and this one also will be positive since we moved it to the other side. But instead of that, we put the value 27.85. And can you find me the answer? So we need to add the product. And to avoid any confusion, you can remove that positive here. So now I want you to tell me what's the value for that tension T. All right, so we start getting the answer. Perfect. So it's 87.85 newtons. Again, I just need to adjust my units. So that answer, if I can say again here, just to make it looks better, T equals, so that's the answer we're trying to find for the first part. So now, if I want to draw the free body diagram, by the way, answers without units are at this stage of the course, they are not acceptable, okay? You must write the units, okay? Especially at this stage of the course. So this is the tension. As we say, there is frictionless pulley, so that we assume that tension is applied as well here. So if now we try to solve this, we need to draw the free body diagram for the second block, which is the 80 in newtons. So I will sketch again. So this is my second block. The second block is easy because it's not inclined. So this is the motion, direction of motion is that way. Again, I need to state that so people, they can understand what we're saying. DMI stands for direction of motion. And what we have, the weight always going downwards. And it should go from the centroid. The magnitude for the weight is 80 newtons. And then what you have on the other direction, you have a friction force going against the direction of the motion. I will give it a red color, and I will call it FF2, because remember there are two, and that's here. So to save my time, that's the one. And also I have a normal force. It's acting towards the here. It's very difficult to show it, so I'll put it here. Which it's in red as well, and that's normal force 2. So we call it N2 because of space. Yeah, excuse my if not getting that enough space. Now, what's interesting here, it's missing, it's the tension, which I haven't done it yet, but that one, it's coming in that way. And now what's the good news? We know the value for that tension. So we can copy that value only, which is the 80, 85. So we say that's the value we're trying to demonstrate here. Make sure to put the units. So that the tension from there. And now we want opposite to that, the force required to pull the object. So that will be P. So that's the free body diagram with direction of motion and everything required. Hopefully it's now clear. I'll move it up just a bit to make sure it's easy to see. Okay, don't mix the newtons with the normal force. So that's kind of an easy free body diagram for that. Now it's very easy. Because of the space, I'll try to use those equations again. So I will shift them a bit here so we don't confuse ourselves, bring them here. And that's the benefit of using digital solutions, so you can be more creative in shifting information. So again, I need to specify my X and Y. See, even previously I did it in that way, but now I'm doing it in that way. So you could always change your X and Y, depends on how you want to solve it. But the most important, you need to tell the reader which direction is your X and Y. And always between them, it's a 90 degree. So this is Control C, this is my Y, and this one is my X coordinate. All right, so we know which direction. So I will copy the first equation to make it easy for me. Control V. So we can delete all of this to not confuse you. So summation of force in the Y direction. What do we have in the Y direction? The normal force into insert normal force into, and opposite to that, if you can see, it's only the weight of the block, so equals to 80 Newton. And because it's perpendicular, so we don't need to perform any analysis on that. That was very easy. Now, if we repeat the same thing for the X direction, I'll copy that equation again to save my time, and then bring it here. And now you can see, I don't need this, so I can remove it at the moment, so to avoid any confusing. All right, don't need the one as well. So what do we have in the X direction now? I'm taking the positive one. We have the P, which is the force we're trying to calculate, minus the 87.85, which is the force resulted from the tension, minus what's the FF2, which is the friction force for the second block or crate. So FF2. Anything there? That's all. See, because the weight is not analysis in two directions equals to 0. Now, I always say we could use this equation again. We just change the numbers, and then we can find FF2. So instead of that, we change it to 2. Instead of N2, N1 will be N2. We keep the value for the coefficients of friction because, as stated in the question, is constant. By the way, sometimes mu is different. The coefficients is different from that block to that block. It depends on the surface of the floor, or as well the crate itself. So here we change the value from 1, so that we say is it's 80 newtons. So what's the answer here? Can you get me the answer for that? So just multiply 80 times 0.268. 21.44. Perfect. Newtons. Perfect. All right. So now since we determined the FF2, then I can reuse this equation again by substituting the values. So that will save me a time. And I will copy this one, bring it here. So if I move this to the other side, I'll show you first. So minus 21.44 equals to 0. Oh, sorry, use the same font to avoid any confusion. 21.44 equals to 0. Now, what we could do instead of that, moving these two numbers on one side, so that's equals to will be positive because we're moving it to the other side, and this one positive as well, and this one will not be equals to 0. What's the value for the force required? So if you add these two numbers, you will get 109.29 newtons. That is the final answer for this question. Well done. Many of you got the answer very correct. So I will give you time to ask any questions. But before that, we can do some kind of summary for the question if we go through it. So if mu, the coefficients of friction for both bodies, this one and these two, the other one is 0.268. Find the force P needed to cause movement towards the right. So these crates or blocks, they will move towards that direction. So because if we take that box, it looks like easy because no incline, no analysis for the weight, but you have two unknown, which is that force and the tension coming from the cable. Well, if we take that box, well, what do you have? You have the tension only unknown and the rest all is known. So you need to determine the friction force and the tension. So we draw the free body diagram, very simple, very easy. It doesn't take a long time. Direction of motion is going upwards and the angle here is 30. You do the analysis. Make sure to show your coordinates, the X and Y, and based on it, you can solve the question using concurrent forces, concurrent system. We have also an equation. The friction force is equal mu n, normal force. The normal force is always opposite to the weight. Since there is only the weight's impact on this question, therefore, you can see it's very easy, will be from summation of forces in y direction, n1 is given, or will be calculated. Since we get the value after rearranging the equation 2, equation 1, rearranging everything, you get the value for t. That t will be applied here. See, when I did draw this again, I didn't put t anymore. I put the number to make sure that I understand what I'm doing, and I have only one unknown, which is called the p, which we're trying to determine. You repeat the steps, but for the second crate, always make sure that mu is same for both or not, because if mu was different for them, then you need to use different coefficients in that equation. You do this steps by algebraic summation of forces x and y. You get the values and then substitute, use the friction equation, and then at the end you will calculate how much or what's the minimum requirements to start the motion or the movement, which is 109.29. Remember, even the crate or this box it's heavier than this one. It's about 120 Newton. Not just that, it's inclined. So kind of you need to lift it up first and then bring it to that level. So it's sometimes it's easy to pull an 80 Newtons on a flat surface. Like you can push a car, you can push for example, a fridge. But if you're going with on the top or is an ingredient and you're going upwards, will be really more tough and you require more energy. In other words, more force to get that job done. So that's the example for it. All right. Right. So we have the second example. Slightly different from the last example which we have done. So mu is 0.5 between the 30 Newtons body and the plane. So there is a friction between these two. Calculate the least value of mu between the 20 Newtons, this one, and the plane to keep them stationary. So there's a condition. So we assume they don't move. And hence find the force between them as well. So there is a force that resulted from the weight of that 30 Newton is pushing downwards. So technically the 20 Newtons start trying to hold the 30 Newtons to prevent it from slipping down. Very good question, very nice. Let's see how can we solve it. So to solve this kind of questions, definitely we need to start drawing the free body diagram. You can do it for both plates, and then we show you how to do it so we can go through it step by step. So first of all, I need to sketch the problem. Let's rotate this. I thought I was doing it in different ways. No, this will confuse you. No, let's do it the easier way. So insert. So this is the line. And we have the first crate, the big one. And then we have the small one next to it. Let's give each one different color. All right, so two of those crates, they are next to each other and they're working on that direction. Let's put the weight for each one of them. So this is the first one. And Control V, Control C, this is the second one. We need to have the values. So this one is 30 newtons and the second one is 20 newtons. Now, one thing we need to demonstrate is how the normal force will react. So I will do something like here first. So that the normal force 1. And we have normal force 2. Remember, the angle between the normal force and the weight is about 30 degrees. So I will put that and make sure to have the degrees. Control C, Control V. So that is 30 degrees and that 30 degrees. Now, if you're wondering how did I got it from that one. All right, let's make this one lighter color. Maybe, yeah, so we can see through. Okay, let's make it more logical so we can do the analysis. Anything else in this example? Now we need to do the analysis for it. So if we want to prevent this crate going, so kind of we need to show you generally, logically, these crates, they should go downwards. And we need to show the friction forces for both of them. And how can we address these two crates? So if by nature, by the weights, these crates, they should slide downwards, and we need to find the friction supports of them. But before that, I need to show the analysis for the weight for each crate. So this is the force. Let's give it red color. And this one is the second one in that way. So Control C, Control V, we repeat the same thing for that one. And Control C, Control V, we repeat the same thing for that one. Not doing it up to scale, so you may find something is funny. So that force, if we put the numbers on each one of them or the equations, this one is, for example, 20 sine 30 degrees. This one. And the other one is 30 sine. This one is 20 cosine 30 degrees. And the other one is 30 cosine 30 degrees. So I'm just pulling all the information as much as we can from the free body diagram. Now, I need to label my normal forces to make sure I have them get them. So this one will be, let's call it insert. So N, we can call this one N1. And Control V, Control C, this one we call it N2. So two normal forces. Why they need as well different forces? Why we didn't treat them as one body? First, because the centroid is different if we treat them differently. And also, that's where my diagram is not really up to the scale. If the centroid is different, then we need kind of to address how can we solve them individually and we get the results for them. So that's all done for that things. Now the only thing is left here we haven't done is the friction force. So how can we sketch the friction force and how can we determine the friction force? So friction force in general, this scenario and logically, not this one, this scenario the motion should goes down, direction of motion. That's in general. Now the reason, because of the weight. So that where is the direction of motion. Now, if that's the direction of motion, now we need to allocate our friction forces 1 and friction forces 2. So let's say this is my friction 1. I would give it a green color so you can see it. I'm not attaching it very close to the, no. I'd give it really very different color. And maybe let's give it more green. Yeah. And the other one, it's kind of here. Goes to prevent. So each one of them will be different. So let's give the first one the name and then the second one. So here, insert, we call the first one friction 1. Make sure to write friction or F1 so we avoid any confusion. Control C, and that will be F1. And then I copy that to make it 2. So here we show the second friction, which is F2. Now, all of that, I have missed one thing, which is the coordinates for X and Y to avoid any confusion. So I will copy it just from the last example to save me time. And then I'll bring it here. So let's say this is my positive X and my positive Y in the direction I'm assuming. So when I solve the example, very easy just to make the assumption, and based on it, you can work and solve any problem as long as everything is assumed correctly and accurate. All right, so now it's all done, but we need to write the equation for that. So if we start with the equation of forces, can you tell me by nature what's the value for N1 and what's the value for N2? Of course, they're coming from algebraic summation equations, but N1 and N2, so N2 is equals to what? The only forces acting on that block downwards against N2 is the 30 cosine 30 degrees. That's the only one we can see. And if you solve that, that will give you about 25.98 newtons. Now, if we try to do the same thing for N2, so that will be, again, equals to what? The 20 cosine 30 degrees. So I'm putting in here, and that will be equals to the value 17.32 newtons. Okay, what's the question? Hi, I know I'm asking this question a little late, but can you please explain why sine and cosine are in opposite directions? What do you mean why sine and cosine are opposite directions? I didn't get that. Sorry, I didn't really understand the question. So do you mean, again, as I remember you guys, if you're moving from the force towards the angle, we always use cosine. If you're going away from it, we always use sine. So the same thing here. 20 cosine 30, and if it's 20 sine 30 if you're going away. That's maybe the easy way how you remember it. Before, sine was on the y-axis and cosine was in x-axis. It's always, did we solve the last example like that? I don't remember. The y-axis is cosine. Y-axis is always cosine. No. Y-axis is always cosine. So I don't see it. You maybe need to see me on Monday so we can explain it in this thing. So always in that way you can get a value for it. All right. So that's the value for the normal forces for both of them. Now, I need to do the algebraic summation of equations in the x direction. So how can we find this together? So if x F and X is equals to 0, and then we write the equation together. Since the F1 and F2, they are different values, I could write this equation in one go, in one long equation. I will do it to you and show you how it works. So the first equation, what will we have? Let's say here, we have FF1, so I'll write that, F1, and then I have minus 20 sine 30 degrees. You can see that. So I started from that end, minus, and then I move. I have minus the other 30 sine 30 degrees. And then I have the FF2, which we say plus because it's going upwards. So it will be FF2, friction force 2. Anything else? Nothing. So technically, that's all what's there. So we took the vertical, the Y forces on the Y, what's is on the Y, and we took all the forces on the X. So the first one, if it's confusing you guys, I would just put that on top of it so you understand. These equations came from solving it in terms of Y, and the second one came from solving it in terms of X. Now, what we know as well, which I'll copy this equation from here, we know there is a relationship between the friction force and the normal force. So if I copy this again, I can say F equals to N2 based on what we described before. So I need to change these value with the mu n. So I replace this with the mu n. So I will repeat this equation again. Insert equation. Let's put it here. Right. So the first value, FF1. What's the mu? So here, a mu for the 20 newtons is unknown. So I will keep it as unknown. I don't know the value for it. Actually, we want to calculate that. So mu times. What's the value for N1? It's 17.32 with brackets to not avoid any confusion. Minus 20 sine 30 degrees. Just put the angle. Minus 30 sine 30 degrees. Put the angle as well. And plus, what do you have? I need to replace FF2 with the mu n. What's the mu? Is 0.5 given to us times N2, which is 25.98 newtons, equals to 0. So very easy. When you write this equation, you generate one equation with one unknown is the coefficient of friction for the crate in the yellow shape, that one. Now I'll give you time. Can you find me the value for mu? So I'll give you time. Can you tell me what's the value for mu? Equals. So if you're confused, I'll show you how it works in your calculator. You bring these together. This will be plus. This will be minus because we're shifting them to the other place, and use square brackets divided by 17.32. And now find the value for mu. What's the value for mu? First answer is correct. I got the first answer, only one answer. So it's correct so far. Any answers? Any tries? Good? No, there's something wrong. The last answer I got is not correct. So I will say the answer is 0.69. That's the correct answer. Please, if you get it wrong, then you need to check your calculations. So that technically is finding the value for mu for that crate or that block or that body, which has different mu. So technically, even if the surface of the floor is the same, but each crate has a different coefficient. And it makes sense. Now, why it makes sense? When the friction increases, see, that's the relationship you need, guys, to understand. If the value for friction increases and the normal force it's small relatively with the weight, that will prevent it from sliding down. All right, so that's where it should guess in it. What's the units for the friction for mu? Do you know what's the unit? Do we know how we measure the unit, by which units? Can you answer this, please? What's the units for the coefficient of? Yes, perfect. Dimensionless, no units. That's a good answer. Now, the second part of this question wants you to determine the force between them. So keep them stationary and hence finds the force between the two bodies. So the force between these two, so we'll write this statement here. Force between blocks equals to what? You have two things you have in between the blocks. So which force are we taking? You have the friction and the normal force. So which one are you taking? Can you find the force between the blocks? The force between them equals to 20 sine 30 degrees minus what? Minus the FF1 or 2, sorry. No, the FF1. The FF1, which we just determined. So sine 30 and then we'll give you, is that correct? So I'll write this equation and you guys tell me if it's correct. So that will be 10 minus 0.693 times the value, which is N17.32. Is that correct? And that will be equals to minus 2.01 Newton. Is that correct? Do you agree with this answer or do you disagree? What's your preference about this answer? Guys, can you see what I'm displaying here or not? Yes, cool. So do you agree with that answer? Do you agree with that answer or not? Oh, Paul is here. Hello. So I'm answering, find the force between the two bodies or the blocks. So do you agree on that? So do you think this is the right answer? Give it time to think about it and then try to find the answer. Cool. Is it correct to have this equation? So if we're trying to find the force between them, so what's the force? You have friction and the weight is going downwards. And you have also here for both of them, so there's a friction going up, or this should be the 30 sine 30 degrees minus the friction, and that will be the 30, which is sine 30 times 30, which is 15, and that 15 multiplied, what's against that force is the friction resulted from the other crate. So the friction force is 17.32 times 0.693, which we just determined, and that will be negative. That will give you as a positive number 2.99 newtons. It depends how you read it, how it should be 0.2. How come it's 0.2? How did you get the 0.2? Because what we have the weight of that crate is pushing down, and against that weight is the friction which is preventing it. Okay, so I will slow down. So if that crate is going there, so it's adding a weight against, or a force against that side of point of contact. So that will be the 30 sine 30 degrees. That's the direction of arrow. Against that, what you have the friction FF1, which is the resulted from what's the normal force multiplied by the coefficients, which is kind of there is a positive force acting downwards. Against that, there is a friction force trying to slow that force. So if you subtract them, you'll find the force between them is about 2.99 newtons in the way how you look into it. All right. So I will cut this and then, okay. So this is example 3. The diagram shows two bodies connected by a light cord passing over a smooth pulley, which means frictionless pulley. If mu is equal to 0.25 for both bodies, calculate the least force P necessary to A, cause motion towards the left. So that's the most important. How can we calculate P will cause motion towards the left? So here is very important to understand the question so you can redraw this free body diagram and show all the components for it. So I will use this free body diagram to show all the components and see what's exactly things you need from it. And how can we determine the values? So that's the the picture we need to analyze. If you look carefully, you have two bodies. The first one is 20 newtons, the third one 30 newtons. And the frictionless pulley, there's a tension here, there is only 30 newtons, friction force here, normal force here, the direction of the motion, so cause motion towards the left. So the P start to be stronger than the 30, and using the gravity acceleration for the 20, and this, both of them, they should move towards left. So the base idea is to start with the 30 newtons free body diagram and find the T, and then you move towards that, and then you find the value for P. Similar to what we done, but now in different direction. So free body diagram, we'll have this one going in that way, and we'll sketch a crate kind of like this. Yes. Slightly. And we'll identify where is the centroid for it. Let's say there, make it a bit darker so we can see exactly where. Yeah, and that will show the value, which is 30 newtons. And also we need to identify where is my normal force. So this one is my normal force. I will give it red. And if that's moving towards the left, then direction of motion, it's going upwards. So that's the direction of motion. So I'll type DOM, direction of motion. I'll just rotate that so make it looks normal. And what else we have? We have the T, which is coming from the chord. So I'll represent that going kind of in that way. So that the T. And I will give it the sample T. T is the same for both free body diagrams to make sure we use the same value. And opposite to the normal force, we should have what we call it. So this is normal 1. And we should have the friction force going downwards. So here it should be friction force 1. F1. Change the font to smaller so you don't confuse like N1 and F2. Change this font to smaller. All right, so yeah, I'm not sketching to really scale, so please ignore my scale is not the perfect at the moment using the software and trying to do this. Again, my positive X and Y, I need to do the analysis for the weight, so that will be going that way. I'll just make it extended so you can see through, and Control C, Control V, and that will be going towards that way. This should be kind of, yeah, should be exactly in that way. I'm just exaggerating the arrows just so you can see through and give me a space to write. That angle, it's 60. So I need to insert the angle. So 60 degrees, not Fahrenheit, sorry. Click the wrong one. And we place it here. So now you have, so technically I can Control C. So that will be 30 cosine . 60 degrees. And the other one is sine 60 degrees. Now we'll just copy that. 30 newtons, sine. Again, for the guys confusing, if I'm moving towards the angle is cosine. If I'm moving far away from the angle is sine. That's the rule for it. Looks like I put everything except the coordinate. I will assume it in that way is positive and upwards is positive. So we can always write the equations as we prefer. So insert the equations. I will start from here. Insert. So equation 1, algebraic summation. So let's say this one, it's summation of forces. What do you recommend? What we start with first? Which one will give me more information? Definitely the perpendicular one, it's recommended because you only have the weight of the block against that. So summation forces in y direction equals to 0. So that one will be equals N1 equals to 30 cosine 60 degrees. If you try now using your calculators, you find N1 is equals to 15 newtons. All right. So sometimes you really need to think which one is the best way to start with, which one we can get more information, and how can we solve this with the shortest solutions. Now, summation of forces in y direction. So I'll repeat this again. Enter the equation, algebraic summations of equations. Now we do the x, f x is equals to 0. And this one equals to, let's see what we have. So we have the first thing is 30 sine 60 degrees. It's going in that way. Plus we have the friction force. So we call it friction F1. And against that, we have minus T, which is the tension resulting from it. That's everything we have in that direction equals to 0. Bring this equation here so they can reorganize the page. Now, FF equals to what? That's funny. When I copy it, it loses function. We type this again to avoid any confusion. So if friction force equals to mu, the coefficients, times the normal force for 1. We put this equation here, and we can, at the same time, we substitute. So what's the mu here as given for both of them is 0.25 times the normal force is 15, and that will give you, if you use your calculator, you find the friction force here. It's equals, I'll use my calculator, so 15 times 0.25, it's 3.75 newtons. That's really very easy and straightforward. Now we substitute that value, FF, in that equation, so we can determine the values for that. So I'll repeat this equation. So instead of FF, we'll have 3.75, and now T. Can you tell me what's the value for T? T equals to what? So T equals the summation of these forces plus, so you have 30 times sine 60 degrees, which is equals to, can you get me the answer, guys? I'll wait for you to give me the answer. Very good. Perfect. 29.73 newtons. Very good. So that answer, we determine the value for T. Now, when we draw the free body diagram for this block, we need to determine the value for the force we try to pull the system. So we sketch another free body diagram in that direction, kind of 30 degrees, and we sketch a block, rotate it in that way. And now we need the weight is always from the centroid going downwards. The weight is equals to 20 newtons. And what we have the tension. So in that direction, we have T. And the value for that, as we say, is 29. And direction of motion is very important to do that. So the direction of motion, we're moving towards downwards. So that's how we're moving. Control C, Control V. So that's the direction of motion. And also we need to show the normal force acting on the block. So the normal force is always going in that way, red. And also we need to show the friction force. So if the direction of motion is going in that way, the friction force is going in that way against the direction of motion, and we call it FF2. And then you give the value for this one, a small tiny one, so you distinguish with it. And here, and 2. Now what's left? We need to do the analysis for the 20 newtons. So first, what's the angle? It's 30, so that angle is 30. So I will copy that number and then just change it to 30. So this one, it should be 30 degrees. And then I will have analysis for the forces, one acting in that way, and the other one, it's going downwards. I'm just putting them, trying to avoid them so they don't interfere with the other ones. So again, if it's going close to the angle, so we use 20 cosine the angle, 30. If it's going far away from the angle, it's sine. So here would be 20 sine 30, because the angle is 30. We can select all of that and we can shift it a bit here to avoid any confusion. All right, so that's the free body diagram for the second block. Now, one thing is missing. I haven't done it yet, which is showing the force P. So that one, it's going in that direction with an angle. So you have two components for it, Control V. So one will be acting in that way, and Control V, and one will be acting in that way. So I'm just showing an arrows a bit far away. I would change them to red so you can see the difference between them. So this one, so if the angle is 20, so that one is sine. So P sine 20. And the other one would be cosine 20. Okay. So just bring this, move it far away from it to avoid any confusing. So that small tiny angle is 20. Is it clear? I know it's required a lot of focusing here and there, but as soon as you do it, you'll find everything's there. You see, too many things we haven't like to know, but the first thing we could start with is to find the friction force. That's what save us time. So friction force 2 equals to what? Mu N2. Now, what's the N2? So that 0.5 instead of 15, here is the tricky thing. It's very difficult to write it in one equation because we don't know the real N2. If you look to N2, what you have 20 cosine 30 degrees. But if you do it that way, it will not help you at all. So it's the best thing to start writing this equation again. Otherwise, we'll confuse ourselves. So summation forces in y direction is equals to 0. You change this one to 2. What do we have? We have 20 cosine 30 and you have negative P sine 20 degrees. It's not equal to 15 anymore because we don't have the value for it. And this one, we call it equation 1. All right. Now that's N2 because we have this one and this one. Both of them, they're acting on the y direction, on the perpendicular direction. Now, I bring this equation to write the second one. So if 2 equals mu times normal force 2. So all of that, you come here and you say 0.25 multiplied by this equation. So now we created kind of equation 2. We're creating too many equations, but I'll show you why, the reason for them. Now, algebraic summation of forces in the x direction. So what do you have in the x direction? 30 sine 60 degrees. We change all of this. We don't need it. Now we start a new equation. So what we have in the x? You have friction, force, and the tension. Friction force, we bring all this together. That's how it works. I know, remember we did in the class was a bit complicated, but that's how it works. So that's the friction force. Plus 29.73, that's the tension, this force. Minus P cosine 20. So I will copy that one. No, it didn't come. Control C. P cosine 30. Also minus the 20 sine 30. It's longest equation, so I will put this here. That will lead to this one. So you see this equation is not really what you think you want to work with. But what's interesting about this equation, it's one equation with one unknown. That unknown is called P, which is the load we try to calculate. It's resulted from adding the normal force. It came in terms of P. And then we multiply that by the coefficients to have it as a friction force 2. And then friction force 2 plus the tension minus this force, which is the weight, the components of the weight, minus the component of the P force in that direction. These are all numbers. As soon as you get that value, you just recalculate everything, and then you will get the answer for this question. I'll give you time to find it. So can you tell me what's the answer for the force in this example? I know it's a bit tricky, but you need to learn how to do it using your calculator. So you need here to expand the 0.25 on this and expand it here, and then you'll have equations with numbers and equations with P. You take the equations with P on one side of the equation and keep the numbers on one side of the equation. Then you simplify, and then you get the load which we're trying to calculate. Right? So I'll give you time to find the value, and then I'll share with you the answer. Anyone answer the answer? All right, any news? The final answer for the P is equals to 23.58 newtons. That's the final answer for this part A. This is only for part A, cause motion towards the left.